There's something strange about water. We like to think we know it, that it's simple, ordinary, everywhere. But the more you look at it, the more it starts to behave like something with secrets. Water is the only substance on Earth that naturally exists as solid, liquid, and gas. That alone makes it feel like it's trying to keep its options open. It flows, it freezes, it floats, it climbs, it bends light, it dissolves mountains, and it somehow holds entire ecosystems inside it. And yet, when scientists talk about water, they still use words like mysterious and not fully understood, which feels almost impossible. We drink it, bathe in it, and depend on it for every biological process we have. But we don't fully understand how it does what it does. You could spend your whole life studying it and still come away thinking, wait, that doesn't make sense. Water is a shapeshifter, a quiet magician that can pull off tricks no other liquid can. If the temperature drops, it expands instead of shrinking. It can climb walls, literally through a process called capillary action, defying gravity just to help a tree have breakfast. It can dissolve more substances than any other liquid on Earth, which makes it the ultimate cleaner and the messiest roommate in the periodic table. But the real mystery begins when you realize that water doesn't just exist in three phases: solid, liquid, and gas, like we were all taught in school. Scientists have found what they call a fourth phase, something between liquid and solid, discovered by Dr. Gerald Pollack at the University of Washington. It's sometimes called structured water or exclusion zone water. What happens when water molecules near a surface start organizing themselves into a repeating, almost crystalline structure? It's like water that's decided to become architecture. These molecules line up in hexagonal patterns, not frozen, but more orderly, a kind of liquid crystal that can store charge, repel particles, and even generate tiny amounts of energy when exposed to light. Now, I know that sounds almost unbelievable, but it's been measured and repeated, and it opened 1,000 new questions. Could it be that the water inside our bodies, the same stuff that makes up about 60% of us, is partly in that structured form? Could this help explain how cells communicate or how plants move nutrients upward without pumps? Nobody knows for sure yet, but that's the beauty of it. The mystery still has room to breathe. Sometimes I think of water like a person who refuses to be summed up. Every time we try, it changes shape, as if to say, nice try. But I'm still more than that. Maybe that's why we're drawn to it. Why we stare at rivers or oceans, melting snow, and feel calm without really knowing why. Because maybe we're built from the same stuff, the same restless, changeable element that's always between one state or another. When I preserve a snowflake, I'm really preserving water mid-thought. A single moment where it decided to stop moving just long enough to reveal what it was dreaming about. And that's what we're exploring here. What water dreams about when it becomes ice, when it listens, when it remembers, and when it changes us without saying a word. If water were a student in chemistry class, it would probably fail the exam. Not because it didn't study, but because it keeps breaking rules. Seriously. Every known physical law says that water should act differently than it does. It's the rebel of the natural world, politely defying expectations with a smile. Let's start with something basic. When most liquids freeze, they contract. They get denser, heavier, more compact, but not water. When it freezes, it expands. And that single act, that strange defiance, is the reason you and I exist. If I sank instead of float, lakes and oceans would freeze from the bottom up. Fish would die, ecosystems would collapse, and every winter would wipe the planet clean. Instead, ice floats, forming a thin protective shell on top of the water, an insulating blanket that keeps life safe beneath it. That's right, one tiny molecular quirk is responsible for nearly all aquatic life, and no one really knows why it's that way. We know it has to do with hydrogen bonds, those fragile connections that make each water molecule a little magnet. But what we don't fully understand is how these bonds rearrange so perfectly to create the solid lattice of ice, or why that structure traps air and expands instead of shrinking. It's like water took one look at physics and said, cute idea, but I have my own plans. Even more bizarre is water's heat captivity. The amount of energy it can absorb before its temperature rises. Water can hold 5 times more heat than sand. That's why beaches are cold at night and hot during the day. Oceans literally stabilize the planet's climate by absorbing excess heat like a global thermostat. Yet again, scientists aren't entirely sure why it holds so much. There's a famous line by Nobel Prize winning physicist Philip Ball. He called water an anomalous. In almost every respect, that's the scientific way of saying we've got no clue. Another one of its magic tricks is cohesion, how it clings to itself. That's what lets it beat up on glass, what makes raindrops fall in pearls instead of mist. Then there's adhesion, how it clings to things. That's why water crawls up a paper towel or travels up a redwood tree, one molecule pulling the next like a microscopic chain of climbers. But here's the wild part. Those same bonds that let water climb trees are what let snowflakes form in the sky. When a water molecule meets a speck of dust in freezing air, it arranges itself accordingly to those tiny magnetic attractions, building hexagon by hexagon, perfectly symmetrical, yet never the same twice. Every snowflake is basically water showing off. We like to think we've mapped its behavior, but even at the atomic level, there are arguments. In 2020, researchers at the University of Stockholm discovered that water might actually exist in 2 distinct liquid forms, one more dense, one less dense, coexisting and constantly shifting between them. That means water doesn't just have 3 faces, it might have moods. Sometimes I imagine water as the shy genius who's been misunderstood for millennia. It lets us drink it, swim in it, paint with it, and still we can't quite grasp what it's made of. A philosopher once said, "You cannot step into the same river twice." I think he meant it philosophically, but it's also true scientifically. The water in that river isn't the same from one moment to the next. Its molecular structure changes every millisecond, rearranging bonds, dissolving minerals, catching sunlight, reflecting clouds. So when you scoop up a handful of snow or watch ice form on a window, what you're really seeing is something in motion. Even when it looks still, water never stops shifting, adapting, reinventing itself. And maybe that's the point. Maybe the reason we're drawn to it, why we find peace near lakes, oceans, and falling snow, is because we recognize ourselves in it. We're constantly changing too. Water is the ultimate reminder that transformation isn't failure. It's just another form of life. There's a story that starts with a whisper, or maybe it's a vibration. Dr. Masaru Emoto believed that water could listen, no ears, not with thought, but with structure. In his famous experiments, he exposed water samples to different sounds, words, and intentions. Some he labeled with words like love or gratitude, others with words like hate or fear. Then he froze the droplets and photographed the crystals that they formed. According to his findings, the kind words created beautiful, symmetrical, snowflake-like structures, while the harsh ones created chaotic, broken forms. Now, not everyone in the scientific community agreed. His methods weren't always reproducible, his controls sometimes questioned, but still, the images struck a chord with millions. Because even if water wasn't feeling, it was responding. And that idea that water reacts to energy, sound, vibration, it's not new. Sound waves absolutely shape matter. Somatics, a field of study that goes back to the 18th century, proves this. If you sprinkle fine sand or powder on a vibrating metal plate, the vibrations make the particles move into intricate geometric patterns. Low frequencies create simple shapes. Higher ones form complex mandalas, nature's dance floor made visible. So maybe Emoto's work was less about proving emotion and more about showing how deeply responsive water really is. After all, water carries sound 5 times faster than air. It absorbs vibration, refracts light, and resonates with frequency. So when someone says, speak kindly, maybe there's more science in that than we thought. The idea of water memory sounds like science fiction, but research keeps edging towards something unusual. Dr. Jacques Benaveste in the 1980s claimed that water could retain the memory of substances once dissolved in it, even after those substances were diluted beyond physical presence. His studies caused an uproar. Some called it pseudoscience, others visionary. Years later, physicist Luc Montagnier, who shared a Nobel Prize for discovering HIV, revisited the idea he found that certain DNA sequences, once dissolved and removed, left measurable electromagnetic signals in the water. The implication wasn't that water has feelings or thoughts. Constantly shifting hydrogen bonds might echo the imprint of what it's encountered. And that's where things get beautifully complicated. Gerald Pollack's work on structured water, the fourth phase, suggests that near certain surfaces, especially biological ones, water organizes itself into layers. These zones can store energy, hold charge, and even expand under light. It behaves more like a living tissue than a passive liquid. Which leads to a quiet question. Could water be a kind of natural recorder? Not consciously, but physically, in the same way that grooves in a vinyl record store sound. If that's true, then every snowflake, every raindrop, every tear might be carrying tiny memories of its journey, written not in words, but in geometry. Every snowflake tells a story about math. Those 6 arms, the branching dendrites, the delicate symmetry, they're all shaped by the laws of geometry and physics. The angle between 2 hydrogen atoms in a water molecule is 104.5 degrees. That little tilt decides everything. Because of it, water crystals naturally form hexagons. Those hexagons grow, split, and repeat in fractal patterns, like the veins of a leaf, the coral reefs, and the galaxies overhead. It's sacred geometry, not in a mystical sense, but in a measurable one. The same mathematics that governs snowflakes governs our bones, our neurons, and the spiral of our DNA. In fact, every snowflake could be seen as the Earth's sketching of a fractal self-portrait. Alex Gray, the visionary artist, once said that geometry is the language of the divine, a bridge between art and physics. And maybe that's why when we look at a snowflake, something in us recognizes. We see the harmony of order and chaos, the way balance emerges from motion. And in that moment, we remember that beauty isn't decoration, it's information. Here's something wild. Every glass of water you've ever drunk has probably passed through a dinosaur. And that's not an exaggeration. The water on Earth is ancient. The same molecules recycled endlessly for billions of years. It evaporates from oceans, becomes vapor, condenses into clouds, freezes into snow, melts into rivers, seeps into roots, flows through veins, and starts again. That means the same molecule that once cooled a volcano might now sit inside your snowflake in your hand. We call it the water cycle, but really it's the planet breathing. Inhale, condensation, exhale, evaporation. And through it all, water keeps adapting, carrying stories across time. Trapped in glaciers, it holds ancient air bubbles, frozen voices of climates past. Released again, it joins modern storms, mixing centuries in a single drop. When I think of it that way, preserving a snowflake feels like holding a piece of Earth's autobiography, something I hope future generations can look back and study. Maybe water doesn't dream the way we do. But if it did, its dreams would be about motion, about connection, about remembering all the places it's been. I sometimes wonder if that's what we feel when we look at snow, that quiet pool of recognition. Maybe we aren't just seeing frozen water, maybe we're seeing a reflection of ourselves. We too are mostly water. We too carry memories of where we've been, some clear, some hidden in layers, and just like a snowflake, we form under pressure, in shifting temperatures, in invisible conditions that shape our geometry. When I preserve a snowflake, I like to imagine I'm pressing pause on that dream, a brief moment when water decided to tell its story in crystal form. Maybe it's just science, maybe it's something more. Either way, I think it's beautiful that even the simplest thing on Earth can still surprise us. And maybe that's the real lesson. The wonder itself, the urge to keep asking why, is proof that we're made of something miraculous too. So next time it rains, or you watch snowfall, or even sip a glass of water, remember it's not just water. It's history, it's memory, it's motion. And if you listen closely enough, you might just hear it dreaming.